These days, people love diamonds. These expensive, shiny, and lovely diamonds exert great power, even among lovers. Look at the couple. Don't they look really happy with the diamond ring? As such, it seems that diamond is playing a big role only in our daily lives. But there are some people who are happier than anyone else to see such diamonds. The quantum scientists. Quantum scientists have a big interest in a special diamond, the NV center in diamond. NV center means Nitrogen Vacancy Center, one of the numerous point defects in diamond. It consists of a nearest neighbor pair, a nitrogen atom plus a lattice vacancy. A nitrogen atom has 5 valence electrons. 3 has covalent bond to the carbon atoms, and remainder 2 non-bonded one are called a lone pair. The vacancy has 3 unpaired electrons. 2 of them make a quasi-covalent bond, and 1 remains unpaired. The 3 unpaired vacancy electrons continuously exchange their roles. Likewise, property of nitrogen plus property of vacancy in diamond consists NV center in diamond. So, what is the relationship between this NV center with quantum? Spins associated to the nitrogen vacancy or NV center in diamond. At this model, some electrons are trapped and formed an electron spin that we can use as a quantum bit. There are 2 states in NV center. The first one is a basic state of an NV center, as we mentioned before, and it is called neutral NV0. The other state is negative NV-. When an extra electron is located at the vacancy site, forming a spin S equals 1 pair with one of the vacancy electrons, NV0 turns into NV-. Now, let's talk about how the NV center makes the photon emit. NV center is well accepted today that has 2 triplet states and 1 intermediate single state according to the LCAO theory. Energy level is divided by the ground state, excited state, and metastable state by the group theory. In the original standard state, in which nothing is given, it has the above energy structure. If the laser is given at the ground state, it is moved to the excited state, an unstable state. In order to escape the excited state, the electron transfers to the metastable state and then go back to the ground state, which releases photon. Moreover, electron in plus minus 1 spin can transfer to the metastable state easily, then electron in 0 spin. Triplet state is made of 2 electrons, which we can stimulate higher energy level by using a green laser. They directly return to their ground state by emission of a photon, resulting in the red light. If a microwave radiation is given at this state, electrons lift into the degenerated state plus minus 1 spin. When we expose the green laser beam, electrons recombine back into 0 spin. It results less intensity of a red light, and we can measure smaller amounts of photoluminescence. Then, let's think about the situation when the magnetic field is applied. If a magnetic field is applied to the axis of the NV center, it makes both of the ground state and excited state split. Spin of 0 state doesn't have any effect, but both of plus minus 1 spin are being splitted into 2 distinct levels due to the Zeeman effect. So, the 2 distinct levels can be occupied through the microwave. If we expose magnetic field, then 2 measurable resonance in the photoluminescence occur. The stronger the magnetic field, the greater the splitting will be. By measuring the minimum frequency of the luminescence, we can determine the magnetic field strength. Then, why do many scientists be enthusiastic for NV center? We need to find out slightly about single photon source, which NV center belongs to. Single photon sources are light sources that emit light as single particles or photons. It is really useful to apply quantum info system. When we use photon as a bit, the photon source should emit a single photon regularly. Why? Because in the quantum communication, multiple photons can be stolen and be vulnerable to security. Otherwise, the single photon source have advantages that can increase security of communication. Thus, we have to develop how to sufficiently make a single photon source, and scientists are working at the ENVI Center in Diamond. Furthermore, these ENVI centers have several unique features that make them promising for quantum info systems. First, the electron spin has long occurrence time, even up to seconds, which means that we can control it as a good qubit. This qubit can even work in a large range of temperatures, all the way up to room temperatures. Second, this electron spin is not the only qubit we have in the system. It couples to nuclear spins in the environment, which give us extra qubits to process quantum info. Also, the electron spin also reacts with photons. This makes it possible to send quantum states far away and entangle ENVI centers over a distance. For these advantages, we can create a quantum networks. Now, let's find out about the use of ENVI center. ENVI center can be used in various fields. One of the examples is magnetic sensing. This is about obtaining the local magnetic information. We use atomic force microscope, AFM, integrated with an ENVI center. This figure shows the magnetic field imaging with AFM. The AFM tip is fabricated from diamond with ENVI center, and tip detects magnetic signal while scanning over the sample. To be specific, ENVI center has total 2 unpaired electrons and forms spin triplet state S equals 1 and its ground level. Magnetic field then detects the measurable resonance in the photoluminescence occur. By measuring the minimum frequency of the luminescence, we can determine the magnetic field strength. This study has advantages that can be applied in the study of materials that changes magnetic orders with temperature change. As such, ENVI center endowment has become a very important element in the quantum information age. We hope that great progress will be made through more and more research. So, this was our lecture for today. Thank you for watching. Please like and subscribe.